This is a recording for geometry for Monday, October 23rd. And today in class, we're writing our new homework, which is homework 4A. And that should be on the sideboard. It should also be on one of the slides for you. Today we're going to be finishing our notes for 2-3. We're going to just add a little bit to that for biconditionals, and then we're going to set up our notes for 2-4, and then we'll continue on with the rest of the lesson tomorrow. So if you would find, first of all, your handout for your 2-3 notes, and you should be seeing this example number 4. It says write the converse, inverse, and contrapositive of the following true statement. Determine the truth value of each statement, and if the statement is false, give a counterexample. And the original statement is bats are animals that can fly. What we're going to do first is we are going to write that as a conditional statement, and I'm going to tell you right now that on your handout for this lesson, you do not have this problem, so you're going to have to find a place in your notebook for this. My suggestion to you is that you go to a new even page. So if that's my spiral, this is the even page, and you're going to continue 2-3 on this, and you'll put number 4 there, and we're going to write several sentences. Then on this left side, the odd page, we're going to add the 2-3 extend work. And so that'll just go on this left page. So you're adding a little bit more to this section, but that way you should have everything that you need for this. So it says bats are animals that can fly. And then I have this little box over here that says bats are not birds, they are mammals. Bats have modified hands and arms that serve as wings. They are the only mammals that can fly. So that's just a little piece of extra information for you as you go. So for this number 4, and again, hopefully this is on an even page, instead of writing bats are animals that can fly, we're going to write the conditional. So the conditional is, the way I'm going to say it is, if an animal is a bat, then it can fly. So if an animal is a bat, comma, then it can fly. And I'll put a little line there just so that I can say if it's true or false. If an animal is a bat, then it can fly, and we know from this little box up here that that is the case. So this is a true conditional. Just to kind of know what I'm doing, I'm going to underline the hypothesis, an animal is a bat, and one time, and I'm going to underline the conclusion twice, it can fly. And then I'm just going to go through the different statements that we've learned about and at the beginning of our handout. And so I will just kind of quickly go to this slide and remind you, because it's been a few days. So these are our related conditionals. I'm going to write on this in yellow, and then I'll get rid of all the yellow. So our conditional is if P then Q. For the converse, we're going to switch the P and Q. So we're going to say if Q, then P. So we're just going to flip it to the backwards. The inverse, we're going to go back to the original order, but we're going to say if not P, then not Q. And then the contrapositive is the one where we do the double flipping. So we go if not Q, then not P. So we flip the order and make them both not. So if not Q, then not P. And we'll just be putting in the words not as we go. So let me get rid of just that writing so it's not there forever. And I'll go back to this slide that we're looking at. and you're writing in your notes. So you have the conditional. Now the next thing we're going to do is we're going to write the converse. So the converse. And when I flip that, I'm actually just going to keep the words an animal in the front and it in the back. And that's okay to do. It'll help it make a better sense as an English sentence. So this one is going to be if an animal can fly, comma, then it is a bat. And if you remember in that box, I can't see it anymore right now, but that the and bat is the only mammal that can fly. So this is going to be a false statement. If an animal can fly, then it is a bat is false. And since it's false, I have to give a counter example. And so I need an animal that can fly but is not a bat. And so I'm going to say a bird can fly but is not a bat. So that is my counter example. And maybe I should have written the word counter example here. Counter example. That makes me think of the quiz for 2122. If you want to retake that quiz, you have until Friday of this week. And I will be available Tuesday after school, Wednesday before after school if you have questions, and you can take it by Friday the 27th. So that's the converse where we go if Q then P. Now we're going to do next the inverse. So the inverse. And remember that goes back to the original order, but not. If not P, then not Q. So this is going to be if an animal is not a bat, comma, then it cannot fly. Cannot fly. And so if an animal is not a bat, then it cannot fly. That is false also. And our counter example, this time I will write the word counter example. Is that a bird is not a bat, but it can fly. Remember, the counter example makes this part work, the hypothesis work, and the conclusion not work. So it's kind of the same counter example as before. So a bird, we just say it a little differently, is not a bat, but it can fly. So there's our counter example for that. Now, the contrapositive, and I'm going to start down here low, but I will put this up a little bit when I'm writing the sentence. The contrapositive is where we flip not only the order, P and Q, so if Q then P, but we also make them not. If not Q, then not P. So this is going to be if an animal cannot fly, then it is not a bat. So let me move this up a bit, and this is if an animal cannot fly, comma, then it is not a bat. And that is a true statement. So that is the contrapositive for this one, and that is what you need to write. I am going to give you some time at the end of this lesson, but the next thing that I'll put up is just a reminder this is the end of this part of the lesson, and you're going to write your level of understanding, your summary, and your questions. But before you do that, I'm going to actually ask that you go on to the left side of this page, and I'll ask that everybody get one of these handouts, and maybe the teacher will give you one of these handouts. You don't have to write the essential question for this one. I'll actually just kind of get rid of that. And you're not going to have to write a separate summary, but you can include this in your summary for this section. And you are going to write, though, and this is actually unusually going to go on that odd page. If you remember a few minutes ago, I said that when we did this lesson, the best place to put that rest of section 2.3, number 4 was over here. Now you're putting this here. This is going to be that 2.3 extend, and you're going to put that on the odd page. And you're good at enough at doing these things that I think you'll be fine in doing this without me. So you're setting this up as 2.3 extra biconditional statements. And then you're going to highlight on this handout biconditional statement. A biconditional statement is the conjunction of a conditional and its converse, and it is read P if and only if Q, and there's a shorter version PIFF Q. And even though it looks like PIFFQ, you read that always as P if and only if Q. If you need to pause this so everybody can kind of write that at least heading and everything in your notes, you may certainly do that. And but now I'm going to go on, and so we're just going to write a single example for this one. And what we're going to do is we're going to write a biconditional first, and then we're going to write it as its conditional and its converse and decide if those are true or false. So this is problem number 1, and the biconditional that you're going to write is an angle is a right angle if and only if its measure is 90. Now, you'll notice if you look up at the symbols up here that they're saying that the P and Q go back and forth, that this is if P then Q, and if Q then P, and then that gives you P if and only if Q, the kind of double arrow, double pointing arrow. So it's read P if and only if Q. A lot of times our book authors will start with the conclusion as the first conditional statement. Since both are going to be what we're looking at, it doesn't matter to me which way you start with. So we'll write our conditional as the following statement, and we're going to write it kind of backwards from the way it is here. So if an angle measures 90 degrees, comma, then it is a right angle. It is a right angle. And I'll put a line there. So if an angle measures 90, then it is a right angle. We know that that is a true statement, so we'll write that that is true. And for the biconditional to be true, both the conditional and its converse have to be true. So now we're going to write the converse. And the converse says that if an angle is right, comma, then it measures 90 degrees. And we'll put a line there. So if an angle is a right angle, it measures 90 degrees. That is also true. And since the conditional and the converse is true, then the biconditional, P if and only if Q, is also true. So both of those have to be true in order for the biconditional statement to be true. And so later this week, I'm going to ask you to do some problems like that just to kind of let you know. But right now, I wanted you to put that in your notes. The next thing I'd like you to do is get a couple more handouts. The handouts that I want you to get are for section 2.4. The first handout looks like that. And the second handout looks like that. They should be in stacks, so hopefully maybe you've even gotten all three of those handouts when you got that last handout. Once you have those handouts, the next things that I'm going to have you do is just set up the next section and write your key terms and highlight on that. And then you can kind of glue everything in today, and then we'll move on in 2.4 tomorrow when I return. So this is section 2.4, deductive reasoning. Can you use deductive reasoning by applying the law of detachment and the law of syllogism? Make sure you write your level of understanding there. And I'm going to actually move on, so you might want to pause this while everybody gets this part done. And then I will go to the next slide. When you're ready, move to this key terms page, and I will also have a couple of these pages on my Smart Note file, so if it's easier to look at them there, you sure can. And in your key terms page, which is going to be that odd page, you're going to define inductive reasoning. Again, even though you've defined it before, uses a pattern of examples to make a conjecture that may or may not be true. You're now going to define deductive reasoning, which uses facts, rules, definitions, or properties to reach a logical conclusion and must be true. And you're going to write something about valid reasoning, which must use deductive reasoning, and the two kinds of valid reasoning, which are the law of detachment and the law of syllogism. Once you do that, then you can go on to looking at these two handouts and highlighting those as you go. And you can pause so that you can see this. Then just a reminder, you should have written homework 4A. Homework 3A is due tomorrow. And these will also be on my Yola site, maybe not until tomorrow. We'll see how that goes. And then a reminder that you can retake that quiz that we had last week on Tuesday through Friday of this week. So I will see you tomorrow. If you have any questions, you can email me as well. Thanks and have a good day.